Hi, I hope everyone's doing well. First of all, let's talk about the quiz. Technically, you would be doing it in class tonight for 30 minutes. Some of you have already submitted it to me. Thank you. Thank you for your funny, corny jokes. If you have not, then try to get it to me by 7:30 tonight. If not, over the weekend is fine as well. All right, just, take a picture of the paper and send it to me, or type out your answers, whatever. The two you have to graph, so obviously send me pictures of those. What else? Let's review a little bit from last time, because the questions I've seen from two of you, you're a little bit confused. So say if you have log base 2 equals 8, okay? It's confusing, right? You're thinking 2 to the 8 equals whatever. No, this is the base. You're looking for the exponent. So that equals 3, okay? In other words, 2 to the what? I think we used y last time, sorry. 2 to the what equals 8. That's what this is asking you. Log of base 2, so the base 2, of what, okay, in this case it's going to be 3, 2 times 2 times 2, equals 8. So this is your base, you're looking for your exponent, and that's the answer. So 2 to the 3 equals 8. 2 times 2 times 2 equals 8. Okay, so hopefully that clears up Tuesday a little bit. All right, let's go on to tonight. 9-5. We're still going to work with that concept more. We're just solving exponential and logarithmic equations. There is no homework, okay, which is due Tuesday. So if the computer pops something up, just ignore it, okay? Solving exponential and logarithmic equations. Okay, so basically what this is saying, there's a one-to-one property of exponential and logarithmic equations. In other words, if a to the x equals a to the y, then x has to equal y. All right, same thing if you have log base a, they're going to confuse you here. Don't relate this to this, okay? Because this is a to the x. This is a to the what equals x. All right, don't ask me why the book used the same variables. And log base a of y. So this is saying, again, if x equals y, okay? But this is a to the x equals a to the y. This is a to the something equals x, and a to the something equals y. Okay, they're different. All right, so let's look at some numbers. This first one, 4 to the x plus 2 equals 64. Okay, if you're not good with your cubes, you might say, huh? But what this is saying, because these have to have the same base for their exponents to be equal, you already know that the base is going to be 4. So what you're looking for is 4 to the what equals 64, okay? So 4 cubed equals 64. 4 times 4 is 16. 16 times 4 is 64. So if we know that 4 cubed equals 64, then 4 to the x plus 2 equals 4 cubed. In other words, x plus 2 equals 3, so then x equals 1. All right, that's all they're asking you for there. In the next one, they have the natural log of 2x minus 3 equals the natural log of 11, okay? So natural log, your base is always going to be e, approximately 2.72. In other words, both of these are e to the something equals 2x minus 3, and e to the something equals 11. So what you could do here is you could just jump straight to it and say 2x minus 3 equals 11, and then solve for 11. Add 3, or I'm sorry, solve for x. 2x equals 14, so x equals 7. Okay. All right, what else? Okay, they're saying in the book, and this makes sense, solving exponential equations. To solve an exponential equation, first isolate the exponential expression, then take the log of each side of the equation and solve for the variable. They're also looking at inverse properties, which you'll need for these. So if you have log base A of a to the x, okay, we had this property before, equals x. And so in other words, a to the what equals a to the x, a to the x equals a to the x. Sorry, my camera is not great just then. And if you were looking at that in natural log, then natural log, we know that's always e of e to the x is going to equal x. In other words, e to the x equals e to the x. Okay? If you had a to the log base a of x equals x, okay? Because what they're saying here is a to the something equals x, and so a to the log base a of x equals x. It's just like the inverse. And same thing here, e to the ln of x equals x, okay? So e to the what equals x? Well, e to the natural log of x equals x. Those are just properties. So let's look at some concrete examples. 2 to the x equals 7, okay? So you want to figure out, well, 2 to the what equals 7, right? You could put it in your calculator, okay? Or you could look at it like this. Log base 2 of 2 to the x equals the log base 2 of 7. Okay? In other words, x equals the log base 2 of 7 because this part is going to be equal to x, like here. So x equals the log base 2 of 7. Okay? And that's approximately, see here you would have to do this by change of bases to figure out what that is. So you could say the ln, of 7 over the ln of 2 is approximately 2.807. Okay? All right. Let's look at that same thing but solving. Do some more. I might do some more on these two, even though I'm not giving you homework on it. All right, that's 9 minutes. Let me cap that off. I'll keep going.